Hello guys, Winston here. My home shop has historically been a bit of a mess. It's a one-car garage with not enough horizontal real estate. Things that end up in here will often wind up stacked on shelves, strewn across my neglected workbench, or piled up on the floor. And yeah, I'm not really proud of it. But recently, I made something to help combat the march of entropy in my garage. This multi-purpose rolling tool cart / miter saw stand. It features a work surface with an area of roughly 30 by 24 inches, 2 tiers of shelving, locking casters at all 4 corners, the beginnings of a pegboard-esque customization system, and my favorite element, 2 folding wings perfectly aligned to serve as outfeed supports for my miter saw and thickness planer. Those who watched my last video about reverse engineering a better dust collection apparatus for my Ryobi miter saw will probably recognize this cart since I used it at several points in that project. After living with this for the past couple weeks, I can safely say that I've been very pleased with both its functionality and sturdiness. Pretty good, right? And the reason it works as well as it does is thanks in no small part to computer-aided design and digital manufacturing. By visualizing my cart on the computer, I was able to iterate and refine the design so it would go together in a nearly foolproof way while utilizing a single sheet of plywood as efficiently as possible. But that's jumping too far ahead. Let's rewind to the beginning. This project has been about a year in the making, ever since I decided to retire this old tool and clamp cart I'd made from 2x4s and a little bit of scrap plywood. The tools and clamps were better off on the wall, and the cart itself provided no functional utility to the shop. What I need the most in my shop is horizontal real estate. I briefly considered constructing a flip-top cart, like the ones that all the cool DIY YouTube makers were building a few years ago, but I know myself. My engineer brain would take a look at existing plans and find some way to scope creep the project into oblivion. I decided that a simple, boring cart, more workbench than cabinet, would be the better solution. Now, I've built 2x4 workbenches before, and the bones of my now butchered CNC enclosure are made of 2x4s as well. Using structural lumber as the bones of a project is a great way to knock together something quick and dirty with a low barrier of entry. But I didn't want to go this route for 2 reasons. First, 2x4s never go together perfectly. Even when you pick through the lumber pile and select the best pieces, the faces are always going to be a little warped or twisted and nothing goes together square. And I'm not about to take the time to process 2x4s with a jointer and a planer just to make a cart. And 2, building with 2x4s means a lot of manual processes, and manual processes create opportunities for small errors to compound. You're going to be measuring and cutting and measuring and drilling and swearing at that defect you didn't catch in the lumberyard. I had a very specific vision for this cart, and I knew my woodworking skills or lack thereof would inevitably betray me. Using plywood, on the other hand, as the basis of my cart means I get to throw a robot at the problem of manufacturing and ensuring that all the features, like these outfeed wings, are integrated with precision. And with a machine like the Shapeoko 5 Pro at my disposal, which is designed to fit materials up to 4 feet wide, this should be totally doable. But there is one wrinkle with choosing plywood as the basis of my cart. Since I don't have a minivan, or a pickup truck, or local friends with minivans or pickup trucks, I can't transport full sheets of plywood. My design needs to be tolerant of the kinds of cuts that can be made in the parking lot of a home improvement center, or on the store's panel saw, assuming it's working or staffed. I swear, those saws seem to be about as reliable as a McDonald's ice cream machine. Anyway, that means I have to plan on my plywood being broken down with a series of straight, simple cuts, and I have to assume those cuts will be of low precision, plus or minus maybe ½ an inch. So I won't be able to nest the parts of my cart across a sheet of plywood like I'm playing Tetris. My design will have to fit within sections no more than 3 feet long. Speaking of design, I want my tool cart to play nice with 3 tools in particular: my miter saw, router table, and thickness planer. The router table is easy, it just needs to sit on a flat surface, but the miter saw and thickness planer would benefit from some extra outfeed support, and I want this to be something easy to deploy without thinking. While there are plenty of functional designs that prop up shelves or wings with a piece of wood or plywood, this means allocating more material for this function, and it doesn't eliminate the need for hardware like hinges that you still have to be able to position pretty precisely. Instead of basic hinges and extra material, I figured the more optimal solution would be a set of 4 folding shelf brackets. I bought this set on Amazon ahead of time so I could take some measurements. In addition to that, I also bought a set of locking casters I thought might be a good fit for this project. These aren't the super premium kind like those leveling machine casters, but they are still noticeably better than sets where only 2 of the wheels lock. Not only does locking these prevent them from rolling, but it also stops them from swiveling. Now, I wanted the cart's footprint to be large enough to fully enclose my miter saw so I could store it on a lower shelf. That meant finding the most compact configuration of my saw and designing around that box dimension. The form factor of my cart ended up developing pretty naturally from my requirements. Wings for outfeed meant that the walls needed to go up 3.5 inches past the main work surface. The width and depth of the cart were dictated by the miter saw, and the height of the middle shelf was designed to fit my router table, mostly. Originally, this cart was designed to be a little taller, putting the miter saw closer to what I thought was an ideal height to use while standing, but once the general form factor of the tool cart was established and I could start roughly laying out where each panel could be cut from a sheet of plywood, I realized that by sacrificing some height, I could ensure the whole cart could be made from a single sheet. And that to me seemed like a good constraint to work around. My first iteration took up so much plywood that I didn't have any left over to make the outfeed wings, and I was planning on making them out of some other scrap material instead, but then I realized that I could get a little creative and nest them inside the footprint of another part. Simply by having any closed-loop structure inside the top and bottom and side panels would already do an excellent job of keeping everything square and providing structural rigidity. Now, alternatively, if I did want to make a drawer for the bottom of my cart, removing some material from underneath would have been an option as well, but making a drawer would also take extra material and I didn't want to do that. To figure out where the folding shelf brackets would go, I needed to find out their mounting hole pattern, which wasn't provided on the online store page. So I did a little measuring and modeling on my own to figure that out. But that's only half the story here. I also needed to position the shelf brackets mounting holes on my cart at the right height so that the plywood supported by it would line up with the work surface of my miter saw, and for that I had to leverage parametric design. Throughout my design process, I was using parameters as placeholders when dimensioning critical features. Whether it was how far down to offset the mounting holes for the outfeed wings, or how wide the slots should be, or how tall I wanted the cart to be. If down the road I wanted to use a different thickness plywood, say 1/2 inch or 3/4 of an inch, I could punch in the new numbers and have Fusion 360 regenerate that 3D model. All the dimensions and positions of features would automatically adjust. I also had a parameter for the gap I wanted in my slots, since machining an 18mm wide channel for 18mm plywood is going to create an impossibly tight friction fit. You need some margin to make parts fit together nicely, and I'd be able to dial that in with this parameter. I think this is one of the best cases I can make for using parametric design software as a maker, be it Fusion, SolidWorks, Onshape, or FreeCAD, or something else. You can design something ahead of time and then update your entire model once you have the final dimensions of critical components. It gives you an insane level of precision and flexibility if you're willing to meet the learning curve head on. Once I had my cart's design locked down and I sketched out how these would be arranged to fit a sheet of plywood, I came up with my cut list to bring to the big box store, Home Depot in this case. I needed 2 panels cut to 30.5 inches, and I'd be able to use the remainder as is. After wrestling a 3/4 inch sheet of plywood onto my cart, I was relieved to find both a panel saw in working order and an associate available to operate it. And while I can neither confirm nor deny that I was hovering over his shoulder, I can report that everything was cut to spec. I loaded the pieces into my car and counted my blessings that I didn't have to do some sheet good surgery in the parking lot. Once I got my plywood to Carbide 3D HQ, I was able to take a thickness measurement and plug that number into Fusion 360, finalizing the 3D model. Toolpathing was conceptually simple. Drill or bore out any holes, pocket the slots, and cut around the perimeters of each pair of panels I'd arranged to fit within my plywood stock. But the reality of machining was where things got complicated. Here's the problem. After sitting for a few days in a different environment and leaning up against a wall, the plywood I got had a little bit of a bow in it now, and there was no good or quick way to get it to sit flat on my CNC. I'd wanted to use double-sided tape for work holding, and that idea had just gone out the window. The plywood was just too stubborn. I don't even think a vacuum table would have been able to manage this job. If my plywood wasn't going to sit flat on the CNC, my slots wouldn't be cut to a consistent depth, then the panels wouldn't sit nicely in those grooves, and then there would be gaps in the glue joints and the cart would come together a little wonky. I had to find a way to force these sheets to sit flat on my Shapeoko, and the only way I figured I could force them to sit flat was to lay them concave up on the bed and liberally apply clamps around the perimeter. But that then posed another challenge, because I didn't have enough extra material margin to keep a frame of fully uncut plywood clamped down to the table while keeping the finished parts in place with tabs. So I came up with a slightly tedious workaround. I went back into Fusion and meticulously broke up my toolpaths. I'd cut the internal features first, then the perimeter contour cuts on the left and right sides, then the contour cuts on the front and back sides of my panels. Between each set of operations, I would play musical chairs with my clamps. Since these contour cuts went all the way through my plywood, it was less essential that my stock be perfectly flat at this stage. This isn't the ideal outcome because it takes more planning and coordination than it ought to, but if a little bit of manual cam fu can minimize the risk of a cut going wrong, I'll happily deal with the extra time required to set it up, especially for a one-off project like this. If I was going into production, I'd need a better plan or better plywood and stock handling. The results as I started machining thankfully matched my expectations. I double-checked my setup at each step in the machining and made sure that I didn't skimp on clamps at any point in the process. Redundancy was my friend. At a couple points, I had a little bit of extra material in my setup, so I sketched some lines for a trace toolpath to follow, which cut me out some straight strips of plywood that I could use later. In the span of one afternoon, I had my parts ready for assembly. An entire sheet of plywood was reduced down to this. I did a little bit of cleanup at home with 320 grit sandpaper on a random orbit sander and gave the surfaces that would see the most wear and tear a couple coats of polyurethane. I know this is just going to be shop furniture, but I felt like this would be an easy way to take a little better care of it and make it last longer. After these panels dried, I started gluing and assembling the cart's pieces together in the order that seemed to make the most sense. Middle shelf to the back panel, add a side panel, add the top panel, and then the other side panel. Along the way, I made use of some reference holes that I'd pecked out on the CNC and opened up by hand. These holes allowed me to drive in some wood screws perfectly into the edges of the plywood panels and seat them fully in their receiving grooves. I expect the glue to provide the majority of the strength here, but the screws are a nice insurance policy, and it allowed me to skip clamping the cart together in many cases, which was nice because I don't have enough big clamps. And the large cutout in the back panel where I'd taken out my outfeed wings ended up being really helpful because I could use smaller clamps to hold the sidewalls and the top to the back panel. There were a couple places where the panels needed some encouragement to fit together, but that was mostly because of the inherent bow in the plywood rather than any variation in thickness of the material itself. Even if I were to make this cart again, I think I would keep the same tolerances because I like how the slots force the plywood to straighten out. On the bottom panel, I'd milled out some counterbore holes that would receive threaded inserts. These would make it easier to bolt on the caster wheels later, and I figured the inserts would be stronger than the wood screws included with the set. After flipping the cart over, I started on attaching the wings. This was the part I was most nervous about, since I hadn't actually done any small-scale integration testing other than figuring out the hole spacing for mounting. But I decided to just YOLO it and started by attaching the outfeed wings to the shelf brackets, screwing into the reference holes drilled with a 16th-inch end mill. Then I screwed the shelf brackets onto the cart. The wings ended up feeling super sturdy, and a quick test with my miter saw on top showed that the height of the outfeed wings was absolutely perfect. I was really happy with that, and there was also adequate room to store the miter saw underneath the cart if I'd be using a different tool on top. And though I hadn't thought about it earlier, the folding shelf brackets were positioned close enough together that I could disengage the locking mechanisms for both single-handed. At the front lip of my work surface on top, I took one of the extra strips of plywood I'd harvested from my stock and glued it to the plywood to reinforce it. That should keep it from sagging over time if I leave something really heavy on top, although the plywood is already pretty well supported along three sides. After playing around with a couple different layouts and organization ideas, I ended up stashing my router table on the middle shelf and then using the bottom compartment to store materials and miscellaneous offcuts. Though my garage floor isn't perfect, so far the cart has rolled quite easily without much wobble. When all four casters are locked, it feels more than stable enough to work on. This project ended up working out really nicely, better than I expected to be honest, and I'm kind of mad at myself for not getting around to it sooner. The main objective of CNC machining everything out of plywood was to be able to plan out all the features I wanted ahead of time in the hopes of making integration a piece of cake. I wanted something resembling the IKEA experience, and in that regard I think it was a great success. Although the plywood I was working with did slow me down a bit, with it refusing to lay flat, if I had higher quality plywood and/or better handling and storage techniques, I think designing projects meant to be made from sheet goods would be something I'd actually enjoy. I'd probably be inclined to make more shop furniture or like furniture. If you're curious about the design of this plywood tool cart, I will have my Fusion files available on Patreon or for like $1.50 on my website. I'm mainly just trying to cover my hosting fees. The project timeline is pretty messy, and I didn't exactly follow the best modeling practices with components and assemblies, so I wouldn't try to glean too much from how the model is designed. But you're more than welcome to take some measurements, learn from my mistakes, and reverse engineer your own plywood tool cart / miter saw stand. Quick announcement before I go, I wanted to shout out an event I'm participating in called the Benchmark CNC Summit, not to be confused with the Machining Summit on the Summit, which is another cool event. This one is an online gathering of some of the leading names in woodworking and digital fabrication with some great presentations and panels lined up. It's a fantastic way to learn from people with a ton of real-world experience, and the best part is, it's free to attend. You can just jump in and watch live. That said, if you think the content would be valuable to you, you can also purchase access to all the sessions and watch them on your own time. That's totally optional, but if you do use the affiliate link in the description below, you're helping to support creators like me and showing the event organizers that there's a real appetite for high-quality CNC content and a really strong community around woodworking in general. No pressure at all, but I hope you'll at least drop in and hang out. That's all I have for today. I want to thank you all very much for watching, and I'll be back soon with more CNC nonsense and DIY mayhem.